Let us now discuss the next topic in the chapter of lines and angles, and that topic is parallel lines. So we will see in this class what are parallel lines and what are the different types of angles that are formed when two or more parallel lines are cut by another line called as the transversal line. Okay, so first of all, what are parallel lines? Parallel lines are those lines which have the same perpendicular distance between them measured at any point. So if you measure the distance between this line A and the line B at any point perpendicularly, the distance will be the same irrespective of whether we measure it here or here or here. Okay, so lines are said to be parallel if the perpendicular distance between them is the same at any point. Okay, and what is the transversal line? The transversal line is the line that cuts through two or more parallel lines. So the red line over here, which we have denoted as line C, is the transversal line because it is cutting through two parallel lines, which is line A and line B. So what we see in this figure is that the transversal line, the red line, is cutting the parallel lines line A and B at two different points, which we have marked in this pink dots here as point E and point F. Okay, now we will see that there are several angles which are formed around these points E and F. So we will see what are those angles, and we will learn the names of those angles, and also we will learn some of the properties of those angles. So first of all, around each of the intersection points, there are four angles that are formed. So around the intersection point E, where the transversal cuts the line A, there are four different angles which are formed, which I have numbered as angle number 1, angle number 2, angle number 3, and angle number 4. Similarly, around the intersection point of the transversal with the second line, which is line B, which the intersection point has been named as point F. There are four angles here, which I have numbered as angle 5, angle 6, angle 7, and angle 8. So now, between these angles, all these numbered angles, angle 1, 2, 3, 4, and angle 5, 6, 7, 8, there are certain relationships and there are certain names for certain pairs of angles. Okay, so first of all, the first definition is what we call as the corresponding angles. The corresponding angles, when in a figure where a transversal is cutting two parallel lines, are the angles that lie at the same location of the intersections. So for example, angle 1 and angle 5 are called as corresponding angles because they are lying on the same location of the intersection point E and F. That means it is lying to the right side of the transversal and above the parallel line here. So that's angle 1. Similarly, angle 5 is lying on the right side of the transversal and above the parallel line. So these are called as corresponding angles. Angle 1 and 5 are corresponding angles. Similarly, angle 2 and 6 are corresponding angles because angle 2 is on the left side of the transversal and above the line, and angle 6 is also on the left side of the transversal and above the parallel line. So 2 and 6 are also corresponding angles. Similarly, angle 3 and angle 7 are corresponding angles, as well as angle 4 and angle 8 are also corresponding angles. So there are four pairs of corresponding angles. So let us write down the four pairs. So the first pair is angle 1 and angle 5. So corresponding angle, the first pair is angle 1 and 5. So let's write down angle 1 and angle 5 is our first pair. The second pair of corresponding angles is angle 2 and angle 6. So let's write down that as well. Angle 2 and angle number 6. The third pair of corresponding angles is angle 3 and angle 7. So let's write that here. Angle 3 and angle 7. And the fourth pair of corresponding angles is angle 4 and angle 8. So angle 4 and angle 8. So there are four pairs of corresponding angles, which is angles 1 and 5, angles 2 and 6, angles 3 and 7, and angles 4 and 8. These are called as corresponding angles because they lie at the same location at each of the intersection points. Okay, now there is a property regarding corresponding angles, and what is that? The property is that the corresponding angles are always equal. So we need to remember this. Corresponding angles are equal. That means angle 1 and angle 5 will have the same value. So whatever is the value of angle 1, we will have the same value for angle 5. For example, if angle 1 has an angle of 110 degrees, 5 will also be 110 degrees. In which case angle 2 will be 70 degrees. That means angle 6 will also be 70 degrees. In which case angle 4 will be 70, as well as angle 8 will be 70 degrees, and so on. Okay, so the corresponding angles will always be equal. So the first thing we need to understand is what are called as corresponding angles, and then we need to remember the property that the corresponding angles are equal. Once we know this, we can apply this idea to solve many of the problems and find their solutions to calculate the appropriate angles. Okay, now let us see the next definition for the angles. It is called as the interior angles. What are interior angles? Interior angles are those angles which lie inside the parallel lines. So there are two parallel lines. These black lines are the parallel lines. Whatever angles lie on the inside, between them, those are called as the interior angles. But the interior angles also lie on the same side of the transversal. So the interior angles will be inside or between the parallel lines within these two directions, and on the same side. That means it will lie either on the right side of the parallel line of the transversal or the left side of the transversal. So the interior angles here, we will find two pairs. The first pair is this one. This is one pair of interior angles. So if I can call this as from our previous notation, it is angle number 1, 2, 3, 4. So this is our angle 4, and this is our angle 5, right? So angle 4 and 5 are our interior angle, the first pair of interior angles. And the second pair of interior angles that we will have is this angle on the left side of the transversal. So they are inside the parallel lines and on the same side of the transversal. So this is, according to our numbering, it's 1, 2, 3, right? So this will be angle 3 and this will be angle number 6, according to the numbering we have used in the previous diagram. Okay, so we have two pairs of interior angles, angle 4 and angle 5, and the second pair is angle 3 and angle 6. So these are the two interior angles, and the property of interior angles is that when we add these two angles, their sum will be 180 degrees. Again, this is a property that we will use in calculating and finding solutions to various problems. So the angles which are on the inside of the parallel lines and on the same side of the transversal, they are called as interior angles. So we see that angle 4 and 5 are inside the parallel lines, that is between them, and they are also on the same side, right hand side of the transversal. Similarly, angle 3 and angle 6 are inside the parallel lines and they are on the same side, that is the left hand side of the transversal. And the sum of these angles will always be 180 degrees. For example, if angle 4 is 70 degrees, then angle 5 will be 110 degrees. So when we add them, it will be 110 plus 70 will be 180 degrees, and so on. So we will see an example later on, but we need to understand first of all what are interior angles, and know that the property is the sum of the interior angles is always going to be 180 degrees. So what it means is angle 4 plus angle 5, angle 4 plus angle number 5 is equal to 180 degrees. Similarly, angle 3 plus angle 6 is equal to 180 degrees. Okay, so angle 4 may be having some value, say for example 60 degrees, then angle 5 should be 120 degrees. If angle 3 is 120 degrees, then angle 6 will be 60 degrees, and so on. The sum of the two interior angles is always 180 degrees. The next definition of the angles is what we call as the exterior angles. The exterior angles, as the name suggests, lie on the outside of the parallel lines and also on the same side of the transversal. So we'll have again here two pairs of exterior angles. The first pair will be outside, means above the parallel line and below the parallel line. So they are outside the parallel lines and they are on the same side of the transversal. So they are outside the parallel lines, outside of this parallel line and outside of the lower parallel line, and also on the same side, that is the right hand side of the transversal line. So as per our numbering, this is our angle number 1 and this is our angle number 8, right? 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. So angle 1 and angle 8 is the first pair of exterior angles, and the second pair of exterior angles will be this angle here. So let me mark here. That's our second pair exterior angle. So it's on the outside of the parallel line and on the left hand side of the transversal. So that's angle number 2 and angle number 7 as per our numbering in our first diagram, right? So angle 1 and angle 8 are exterior angles. That's the first pair of exterior angles. And angle 2 and angle 7 is our second pair of exterior angles. And the property for exterior angles is the same as the property for the interior angles. That is, the sum of the exterior angles is also 180 degrees. That means angle 1 plus angle 8 will be 180 degrees. So angle 1 plus angle 8 will be 180 degrees, and angle 2 plus angle 7 is also equal to 180 degrees. So that's our property for exterior angles. Let us now look at the next type of angles, which are also interior and exterior angles, but with a small difference. These are called as the alternate interior angles and the alternate exterior angles. So what do we mean by alternate interior angles? First of all, if it's interior angles, it means they lie inside the parallel lines. So for example, here inside the parallel line, we have this particular angle here, which is our angle number 4. But in this case, we want the alternate interior angle. That means it should not lie on the same side, but on opposite side of the transversal. So you want an angle which is inside the parallel line, but on the opposite side of the transversal. Because this is on the right hand side, the other angle inside and the opposite side of the transversal will be on the left hand side of the transversal and inside the parallel line. So it will be this angle here. So that's opposite side. So angle 4 is on the right side of the transversal, and this is our angle 6, angle number 6. So that's our alternate interior angle. It is inside the parallel lines and on opposite sides of the transversal. So angle 4 is on the right hand side of transversal and angle 6 is on the left hand side of the transversal, and both 4 and 6 are between the parallel lines, so they are alternate interior angles. So angle 4 and angle 6 is the first pair of alternate interior angles, and the property of these alternate angles is that they are equal. Okay, alternate angles will also be equal all the time if we have a transversal cutting through 2 or more parallel lines. The next pair of alternate interior angles will be this inside angle on the left side of the transversal and this interior angle on the right side of the transversal. So according to our numbering, this is angle 1, angle 2. So this is angle number 3. So we'll write this as angle 3. And this is our angle 5, 6, 7, 8. So this is angle 5. So we'll write angle number 5 for this. Okay, so angle 4 and angle 6 are alternate interior angles, as well as angle 3 and angle 5 are also an alternate pair or alternate interior angles pair. Okay, and what is the property about alternate interior angles? The property is that alternate angles are equal. So that means angle 4 and angle 6 will be the same, angle 3 and angle 5 will be the same. Okay, so that means angle 4 will be equal to angle 6 and angle 3 will be equal to angle 5. So alternate angles are equal. Similarly, we can have alternate exterior angles. So as the name suggests, they are exterior and alternate. Exterior means they lie outside the parallel lines. So the first angle that we can talk about is, so let's take this angle which is lying outside the parallel line, and that's our angle number 1, and this particular angle is outside and to the right hand side of the transversal. Similarly, for the bottom parallel line, the angle lying on the outside and to the left of the transversal will be its pair. So it will be this angle over here. So according to our numbering, this is 1, 2, 3, 4. So this should be 5, 6, 7 and 8, right? So this is 7. So this is angle number 7. So angle 1 and angle 7 are alternate exterior angles. So that's the first pair of alternate exterior angles. Similarly, the next alternate exterior angle will be angle 2, which is on that side. Let me use a different color for that. So that will be our angle 2, and that's on the left hand side of the transversal. So we need to choose the exterior angle to the right hand side of the transversal here. So that will be this particular angle here, and that's our angle number 8. So we have angle 2 and 8 is the second pair of alternate exterior angles, and the property is that the alternate exterior angles are also equal. So that means angle 1 is equal to angle 7, and angle 2 is equal to angle number 8. Okay, so we have seen now what are corresponding angles, what are interior angles, and now what are alternate interior and alternate exterior angles as well as exterior angles. Okay, so I've seen 5 types of angles so far: corresponding angles, interior angles and exterior angles, and now we have seen alternate interior angles and alternate exterior angles, and we have seen the properties of each of those. Let us now work out an example by giving some values to these angles. Let's say we give some value to the angle number 1, and from there we'll go on to calculate the rest of all the angles. And to do that calculation, to find out all the remaining angles just by knowing one of the angles, we will use our ideas from the previous class, which is linear pairs of angles and angles when two lines intersect each other. Okay, if you remember, for linear pairs of angles, if there are two adjacent angles where the non-common arms form a straight line, the sum of the adjacent angles is 180 degrees. Okay, or when there is a ray standing on a line, the adjacent angles which are lying on the either side of that ray will have a sum equal to 180 degrees. That's the idea we use in linear pair of angles. And then we also saw in our intersection of two lines that vertically opposite angles are equal. Okay, so we're going to use just these two ideas to calculate all of our angles, and then we will show all the properties that we have discussed so far over here. So let's take this example here. So we have our angle number 1 given to us as 100 degrees, and we are asked to find all the other angles. So we are asked to find what is angle number 2, what is angle number 3, how much is angle number 4, how much is angle number 5, how much is angle number 6, how much is angle number 7, and how much is angle number 8. Okay, we want to calculate each of these. So for the first step, Just because we know we are given angle number 1 to be equal to 100 degrees, we can easily find what is angle number 2. Because if you just look at this line, the straight line, and consider this red line as a ray standing on that straight line, that means the sum of angle 1 and 2 should be 180 degrees because it's the angle on a straight line. So angle 1 and angle 2 are adjacent angles whose non-common arms are forming a straight line. So therefore, the sum of angle 1 and 2 should be 180 degrees. So therefore, because we know angle 1 is 100 degrees, angle 2 will be 80 degrees because sum of the two should be 180 degrees. So by linear pair of angles rule, by linear pair of angles rule, angle 1 plus angle 2 should be 180 degrees. So we know angle 1 is 100 degrees. So 100 degrees plus angle 2 equals 180 degrees. So therefore, angle 2 is equal to 180 degrees minus 100 degrees, which is equal to 80 degrees. So we have found angle 2. So angle 2 here is equal to, so I'll write this here as 80 degrees. Okay. From this, we can now calculate the value for angle number 4 as well as the value for angle number 3. So if you look at these two, this black line, the first parallel line on top, and the red line, the transversal, and just for a moment imagine that the lower parallel line does not exist. Okay, this is basically like two lines intersecting each other, and we know that for two lines which are intersecting one another, the vertically opposite angles are equal. So that means angle 1 and angle 3 must be the same because they are vertically opposite to each other. Similarly, angle 2 and angle 4 must be equal because they are vertically opposite to each other. So for intersecting lines, vertically opposite angles are equal. So we will use that rule and find out what is angle 3 and angle 4. For intersecting lines, vertically opposite angles are equal. So therefore, we can say angle 3 is equal to angle 1 and angle 4 is equal to angle 2. So angle 3, which is equal to angle 1, that means angle 1 is 100 degrees, so angle 3 will also be 100 degrees, and angle 4 is equal to angle 2, so that means it also is going to be the same as angle 2, which is 80 degrees. So we know angle 3 is 100 degrees, so this will be 100 degrees, and angle 4 is again 80 degrees. So we have now all the four angles around the first intersection point of the first line, so of this intersection here. So we have all the four angles around that intersection which are marked in blue. Similarly, we can now calculate the intersection points around the second intersection point, which I'll mark in pink here. So around this, we want to calculate angles 5, 6, 7, and 8. And for this, we will use the rule for corresponding angles. So if you recall, in the beginning of this class, we said the angles which lie at the same location around the point of intersection are called as corresponding angles, right? Angle 1 and angle 5 are corresponding angles. Angle 4 and 8 are corresponding angles. Angle 2 and 6 are corresponding angles, and angle 3 and 7 are corresponding angles. And the property of corresponding angles is that the corresponding angles are equal. So that means angle 1 and angle 5 are same. That means angle 5 is the same as angle 1. So we will use the corresponding angles rule. So let me write down using corresponding angles rule. Angle 5 must be equal to angle 1. Angle number 5 must be equal to angle 1, which is equal to 100 degrees. So angle 5 is equal to 100. So angle 5 will be 100 degrees. Similarly, angle 6 will be the same as angle 2. So angle 6 is the same as angle 2. So 2 and 6 are corresponding angles. So that means 6 is the same as angle 2, which is 80 degrees. And angle 3 will be the same as angle 7. Angle 3 and 7 are corresponding angles. So that means angle 7 must be equal to angle 3, which is 100 degrees. And the final pair of corresponding angles is angles 4 and 8. That means angle 8 must be equal to angle 4, which is also equal to 80 degrees. So we'll have 100, and we'll have, for angle 6, we'll have it as 80 degrees. For angle 7, we'll have it as 100 degrees. And for angle 8, we'll once again have it as 80 degrees. Okay, so we have all the angles here. So I'll just mark this as angle 2, angle 3, angle 4, angle 6, angle 5, angle 7, and angle 8, right? So we have all the angles over here, and we have got all the values. So we can now verify all the properties that we have seen so far. So first is that the corresponding angles are equal. So by using that property, we have obtained these values for 5, 6, 7, and 8. So that is already proved. Let us now verify about the interior angles. Okay, we saw that for interior angles, the sum of the interior angles is 180 degrees. So we see that sum of the interior angles is 180 degrees. So let's prove that. So when we look at this, the interior angles, which is angle 4 and 5, angle 4 is 80 degrees, angle 5 is 100 degrees. Interior angles lying on the same side of the transversal, on the right side here. So 80 plus 100 is 180. Similarly, interior angles to the left side of the transversal, we have 100 and 80 for 3 and 6. So 100 plus 80 is 180 degrees. So sum of the interior angles is 180 degrees. Similarly, for the exterior angles, the sum of the exterior angles is also 180 degrees. So angle 1 and angle 8 are exterior angles. So angle 1 here is 100 degrees and angle 8 is 80 degrees. So this is exterior angle on the right hand side of the transversal, that is on the same side of the transversal. So 100 plus 80 is 180. Similarly, exterior angle 2 and 7, if we add them, we get 80 plus 100, also 180. So sum of the interior angles is 180. Sum of the exterior angles is also 180. So we can see that all the properties that we have seen are being verified in this example. Okay, the next property we saw is alternate angles. Alternate angles, we saw that alternate angles are equal. So what are the alternate angles? We have alternate interior angles or alternate exterior angles. So the alternate interior angle is the angle inside the parallel line, but on the right and left side, opposite sides of the transversal. So we have angle 4, which is inside the parallel line, to the right of the transversal, and angle 6 inside the parallel line but to the left of the transversal. So we see both the values for angle 4 and angle 6 are the same, 80 degrees and 80 degrees. Similarly, interior alternate angles 5 and 3, they are also same. So we have angle 3, which is inside the parallel line to the left of the transversal, and angle 5 inside the parallel lines to the right of the transversal. So angle 3 and angle 5 both have a value of 100 degrees and they are equal. So this property is also proved. Alternate interior angles have equal value. So we have seen that the corresponding angles are equal. The interior angles add up to 180 degrees and the alternate angles have the same value. Similarly, we can see the alternate exterior angles. So we have alternate exterior angle here, which is angle number 1. The corresponding exterior alternate angle is angle 7. It is outside the parallel line to the right of the transversal. This is outside the parallel line to the left of the transversal. So we see that they are the same value, angle 1 and angle 7. Similarly, angle 2 and angle 8, they are alternate exterior angles. So we verify all the properties that the corresponding angles are equal, the alternate angles are also equal, and the sum of the interior angles is 180 degrees. Okay, so we have verified all the properties. So for parallel lines, we have different types of angles which are formed, and each of those angles have certain properties, and we have seen what those properties are and also verified those properties by means of this particular example. Now that we are equipped with all the ideas related to parallel lines and the angles formed when two or more parallel lines are cut by a transversal, let us try to do some exercises and have a better understanding of the concept by applying the concept to some real situation. So let us do some exercise here, and for that we are going to prove a particular theorem here, which says that if we have two lines which are parallel to a single line, then the two lines are also going to be parallel to each other. Okay, in this case we are given three lines, line L, line M, and line N. We have three lines, and what we have been told is that this line M, which is this line, is parallel to this line L, and we are also told that this line N is parallel to line L. And we need to prove that if line M is parallel to L and line N is also parallel to L, then whether M and N are also parallel to each other. The theorem says that lines which are parallel to the same line are also parallel to each other. So that's what the theorem says. So if M is parallel to L and N is also parallel to L, then that means M and N are also parallel to each other. So this is what we need to prove here. To prove this, we'll use the properties that we have seen now. So let's take our corresponding angles property. So we will have our corresponding angle for line L and line M. Okay, so if we call this angle over here as angle number 1, okay, and the corresponding angle on line M here is angle number 2. What is the relationship between angle 1 and 2? Because we are given that line M and line L are parallel to each other, these two lines indicate is the notation for parallel. So line L and line M are parallel to each other. That means 1 and 2 are corresponding angles, and the property of corresponding angles is that they are equal. So therefore angle 1 is equal to angle 2. So that's right. Since line M is parallel to line L, angle 1 and angle 2 are corresponding angles. Okay, so therefore, because they are corresponding angles, therefore angle 1 is equal to angle 2. Now the next piece of information we are given is that line N is parallel to line L. So just imagine that this line M does not exist at all now. If you just think that this is not even existing, just consider L and N now. These are parallel to each other, that is given to us. So the corresponding angle for angle 1 on the line L is this particular angle to the right side of the transversal, and we will simply give it a name as angle 3. So that's the corresponding angle for angle 1 on the line N. Now what is the relationship between angle 1 and angle 3? Because they are corresponding angles, since we know that line N is parallel to line L, we say that angle 1 and angle 3 are equal. So again, since line N is parallel to line L, angles 1 and 3 are also corresponding angles. Angles 1 and angle 3 are corresponding angles. Therefore, angle 1 is equal to angle 3. So now, if we look at these two expressions, if I call this as equation number 1 and this as equation number 2, we see that we are saying here that angle 1 is equal to angle 2, and we are saying that angle 1 is also equal to angle 3. That means in this equation, the left hand side is the same. That means the right hand side must also be the same, right? So that means angle 2 must be equal to angle 3. So combining 1 and 2, okay, we can write combining equation 1 and equation 2, we can say angle 2 is equal to angle 3, and if angle 2 is equal to angle 3, that means angle 2 and 3 are corresponding angles, and that can be true only when line M and line N are also parallel to each other. So this is the converse of this. Previously we said if the lines are parallel to each other, the corresponding angles are equal. Now we are seeing that since the corresponding angles are equal, then the lines must be parallel to each other. This is the converse of the original property, that the corresponding angles are equal. So instead of saying if the lines are parallel, the corresponding angles are equal, we are saying this rule in the reverse direction, where we say that since the corresponding angles are equal, therefore the lines are parallel. Okay, so we can say angle 2 is equal to angle 3. And now let me write the conclusion on this particular box here. Okay, since corresponding angles angle 2 and angle 3 are equal, line M is parallel to line N. Okay, so we have proved that line M is parallel to line L because the corresponding angles 2 and 3 are shown to be equal by these two equations, equation 1 and equation number 2. Okay, so that's our first example where we have applied our idea about corresponding angles to prove certain aspect of parallel lines, that or to prove this particular theorem here, that if we have two lines which are parallel to one particular line, then these two lines are also parallel to each other. Okay, let us now do one more example as an exercise and we will wind up this topic. So this is our second example here. Again, here we have three parallel lines, AB, CD and EF, and it is given to us that AB and CD are parallel to each other and CD and EF are also parallel to each other. That means all three lines are parallel with respect to each other. And we are given that the angle of Y and angle of Z, okay, have a ratio of 3:7. Okay, so based on this we are asked to find what is the value of the angle X here. So to find the value of Y, what we have to notice is we have to mark the corresponding angle for Y in the bottom line. So the corresponding angle for Y in the bottom parallel line, then the line EF, is going to be this line. So the corresponding angle here is going to be this. So that's also going to be Y. And because it's corresponding angle, it will be having the same value as Y. So we can simply write this also as Y, because this is on the left hand side of the transversal and above the parallel line. So this is also on the left hand side of the transversal line and above the parallel line. So it is the corresponding angle. So now we are given that the ratio of Y is to Z is 3:7. So that means this total angle Y plus Z is divided into 10 parts, out of the 10 parts, 3 parts are taken by y and 7 parts are taken by z. So what is the total angle on this particular line? Again, our idea from the previous class, which is linear pair of angles. This is a line and this is a ray standing on that line. So we have two adjacent angles with the two non-common arms forming a straight line. So therefore, the sum of y and z is 180 degrees. So using the linear pair of angles property, using linear pair of angles property, okay, y plus z should be 180 degrees. Okay, so and y and z are in the ratio of 3:7. So we are going to divide 180 into 10 parts. Out of that, 3 parts are belonging to y. So y will be 3 parts out of the 10 parts of the 180 degrees of, let me write that properly, of the 180 degrees. So that will be equal to 54 degrees. So y is equal to 54 degrees. From that, we can now calculate z. We can calculate z as 180 minus 54, or we can calculate it as 7 parts out of the 10 parts into 180 degrees. That will be equal to 126 degrees. So z is 126 degrees. So we could have also calculated z as 180 minus 54 also, and verify the answer also. Z equals 180 minus y, which is 180 minus 54, which is equal to 126 degrees. So we get the same answer. We could have calculated z either from this expression after calculating y, or using the ratio as well. It will give us the same answer. Okay, so we now have the value for y and z. We now have what we want to find is the value for x. So we have the z equal to 126 degrees. So z equals 126 degrees. So from this we can now write the vertically opposite angle to z. Okay, the vertically opposite angle to z. If we look at this line, the red line and the black line intersection, this angle here is the vertically opposite angle to z, and we know that the vertically opposite angles are equal. So this angle here is also 126 degrees, and if this is 126 degrees, x should also be 126 degrees, because x is the corresponding angle to this 126 degrees, because it is on the left side of the transversal below the parallel line. This is also on the left side of the transversal below the parallel line. So this angle here is 126 degrees by the rule of the vertically opposite angles for this intersection, and by using the corresponding angles rule, x is equal to 126 degrees. Okay, that's one way of doing it. Okay, by using corresponding angles property, x equals 126 degrees. Okay, another way of doing it could have been, we know this is z. The corresponding angle for z on this line here is this angle. Okay, so this angle here is the corresponding angle for z, so that also will be 126 degrees, and the corresponding angle here is also 126 degrees. So we have 126, 126, 126 here, right? So these are all corresponding angles, and once we have reached here, we can look at these two as intersecting lines. So, and the vertically opposite angle for this here is x. So the vertically opposite to this 126 is this x. So x will be equal to 126 degrees as well. X equal to 126 degrees. Okay, So let me not write it there to avoid any confusion. So x here 126 degrees. So we have done this in two different ways. We can use, there is multiple ways of solving this. We can use any of the methods. We can apply any of the properties that we are familiar with. As long as it is applied correctly, we will be fine. So the value of x is equal to 126